This is Datum's no-code application builder. A researcher or a biomedical scientist would come in and either create an account or log in. I already have an account, so I'm logging in. They would land onto the homepage of the builder where they can see pre-built canvases. They can create a new one. They can name their canvas. Here I will be building out a very simple flow for warfarin. This is a prompt for the system to look up the right guidelines for warfarin. Basically here, I've built out the part of the flow off screen, so I'm not going to show that. Here you can see the name of the drug and questions about the patient history. If I wanted to modify an existing flow, I would simply add a new box and edit the flow. As clinicians are creating these flows, this clinical knowledge is also being captured and incorporated within the knowledge graph in the form of directed acyclic graphs or DAGs. The advantage of this is that you can run analytics on this data. This is an example of a simple use case of creating a drug-gene interaction flow for warfarin. This pharmacogenomic clinical decision support tool is the first of many applications we will be building using our platform. Here I'm acting as a clinician and building out this flow, creating simple questions and response options in the flow. When we actually have EHR integration, we'll be pulling all this information from the EHR so that the clinician doesn't have to write these questions out themselves. We'll simply pull these details and populate the flow, including information on the patient's genetic information if it is available. The reason we're creating a flow in this way for now is we can deploy this independently as a web app, so all pharmacists all over the world can start using it, even if they don't have any EHR tools available at hand. They'll also be able to input these details manually and get the recommendations for their patients directly from our tool. So once the clinician has created the flow, as you can see on the right-hand side, they can preview and basically they can go through the web app as if in a normal web app, and we can directly deploy this. We recently incorporated LLMs into the flow builder, so I'm going to show you a couple examples of that. We took OpenAI's GPT-4 and fine-tuned on the clinician-built flows we have so far to get the results. What this does is it'll automatically populate these flows, as you can see here. So basically, it's the same way GitHub Copilot runs. The clinician, in our case, will be able to select the flow that closely matches what they have in mind, and they can modify the flow to get to the final application. There is significant latency. As you can see, it's pretty slow. This is because we need to improve it with more compute, more fine-tuning, and high-quality data. But let's see how it goes. So, okay, it looks like this is not the right flow that I'm expecting. As a clinician, I would just say this is not good enough. I would look through all of it and say regenerate. It has regenerated another flow. So looking through this, it doesn't look like it's good enough still. Which means I will regenerate again. And basically doing this a few times will help train the LLM better. And this is saving me time. And since all this data is coming from the underlying knowledge graph, which is just a collection of facts from CPIC guidelines and FDA tables, chances are the LLM being trained is not going to be providing the incorrect information. Obviously, this is still chances of hallucination. But given that it's coming from the knowledge base, that is significantly reduced.